Welcome to M Curious. James Webb Space Telescope is finally on its way to L2. It will take 6 months to get the first image from it. In this video, you will get to know what are the main goals of Webb. Webb is a powerful time machine that will take us back in 13.5 billion years back in time, and let us see how and when the first light in the universe was produced. It will let us see the first stars and galaxies forming out in the darkness. To see back in time, infrared resolution will play a very crucial role. After the Big Bang, the universe was a pretty dark hot place. It was full of particle-like protons, neutrons, and electrons. When the universe started to cool, proton, electron and neutrons combined to form an atom. Then after some time, the first sources of light were formed, but how the first light looked like and where it formed we don't know. But we will know with the help of Webb. To see the light which was formed nearly about 13.6 billion years ago, we need an infrared telescope because the light which was formed 13.6 billion years ago. During this long propagation of light, its wavelength has been shifted toward the red and further into the infrared region of the spectrum. That's because when seeing distant object, Einstein's general relativity comes into the picture. This tells us that the expansion of the universe stretches space between the galaxies and move it away from each other. So, any light in between will also stretch, causing the wavelength to appear longer. This makes distant objects very dim because their wavelength stretches away from visible light to infrared light. So, redshift means that light emitted by the first galaxy or star is emitted in visible light, but it gets shifted toward the redder wavelength by the time we see it here and now. That is the reason why the infrared resolution is so important to detect the first light and galaxy in the universe. The galaxy shows us how matter in the universe is organized. The study of a galaxy tells us about the distribution of matter in the universe and the nature and history of the universe. But, the distribution of mass or matter in the universe was not the same all the time. So, the galaxy which we see today is mostly of spiral and elliptical type, but it was not always like that. These galaxies were formed over billions of years, by several different processes which are occurred by different events like the collision of a small galaxy. So if we look back over billions of years, we see a very different picture. So Webb will tell us how these galaxies were formed and evolved, by observing them in past at the exact time of their evolution. James Webb will also help us to understand the formation of stars and the planetary system by taking the images within the infrared region of the spectrum. This will help us to see the star which was hidden in the dust of the nebula before. It was not possible to see stars which are just born and hidden in the clouds within the visible light. Visible light gets scattered because of dust. But if we see it in the infrared and with improved spectroscopy, it will be easier to spot all the hidden stars in the cloud. And also help to find the evidence of life-forming elements in the dust of just newborn stars, which are in process of forming the planets. So these are all the main goals of the James Webb Space Telescope. But we don't know what other unexpected discovery we might get. But we surely know that there is a lot of surprises are waiting for us. Thank you for watching this. And for more stuff like this, please subscribe to these channels.